welcome to this episode of Future Talks, an interview-style podcast for FuturePart. My name is Nisha van der Hoven, and today's guests are Gordon Jubber, one of our core members of FuturePart and senior architect within Boogertman Partners Architects, as well as Herman Jansen, a facade specialist within Boogertman Partners Architects. Welcome.
Thanks.
Today we'll be talking about a unique set of parameters that influence the design of the NF Towers building in Accra, Ghana, a project that you both worked on.
Yeah.
Now, the NF Towers project was an international competition in 2015, if I believe.
Correct.
How did this competition come about, and what led Boogertman Partners to participate in such a competition?
It was a by invitation competition,
Okay.
so it was sent out to a selection of 5 or 6 firms, mainly through local partners in Ghana. We currently have a long-standing relationship with Multicad in Accra, where we've executed already several projects, initially retail and recently SU and 335. The international teams consisted of teams from Italy. The Italian team already quite known for their work with Airport Square 1, which is quite a well-publicized building. Teams from Greece, France, and then also another team from South Africa.
Did you partner with a local Ghanaian architect as part of the submission?
Yes, we did. So with Multicad, we developed the project from start to finish. It was also our partner into the construction period.
Okay. So how did your proposal actually respond to the competition brief? I mean, specifically the local context and the seismic conditions of that particular region.
We were inspired by Shop's approach, where you normally have the saying like form follows function. With Shop has a saying form follows performance, and we decided to rather take performance to the ultimate and see what the result of the performance would be, as opposed to dictating, or the performance being dictated by the aesthetic appearance.
Right. I mean, obviously the glass tower is actually quite a bold design statement. So where did this particular shape actually originate? And of course, how did it evolve into this twisted form?
The original concept was that it's a small constrained site, and one of the difficult parts of the brief was there was a requirement for extremely small floor plates, I think in the region of about 900 square meters, which doesn't really make sense for a high-rise building, meaning especially because of the size of the core. Ideally you want a floor plate within the region of about 1,000, 3,400 square meters. But it comes back to one of the fundamental differences with working in a place as Accra, where tenancies also tends to be a lot smaller. Here we would normally look at dividing the floor in about 4 to 6. There they would drop it down to 60 to 90 square meters per tenant.
Wow. Okay.
But with this specific competition, it was for one client. So essentially, even if because of the site parameters or the site constraints, it was, even if you just made it an extruded square, it was still it was a big, sort of short, stumpy type building. We rather decided, okay, well, let's not go that route. Let's rather explore different building typologies, especially from an environmental performance aspect. We explored different typologies, and we basically also came to the conclusion that an H-shaped profile essentially would be the best. It's a by far more healthier typology, especially in terms of the amount of viewable surface you generate. It's more expensive typology. It's not necessarily cheaper.
Because more facade area.
Yeah. But we have very different with for instance within Accra we're close to the equator, so sun works different than here. So you basically have north-south sun. You have sun moving vertically over the building. So ideally what you want to do in these sort of conditions is shade the building. So for starters, a glass building is not necessarily the correct response to that specific climate, but by exploring the typology and then to what extent what benefits and performance benefits, especially we can gain from the H typology, we sort of discovered that, one thing is we have the H typology, and you have at least a sense of the two wings shading each other, in a sense, so it's not completely exposed at the same time. We then realized that, if we stagger the wings as well, we can get a better performance in terms of east-west control.
Right, okay.
And then we also then further explored, there was another interesting component to the building, being that it's a mixed-use building, but that the bottom of the building basically needed to respond to the side. The vertical part actually had to twist. And that's in terms of, because of the hotel, so it needs to look at the sea, the ocean, it needs to look at the city.
Okay.
And that's basically where the twist of the building started. But one of the things we ran extensive wind and solar analysis to basically establish the effect of any typology change, and whether what works and what doesn't work. And what we didn't actually realize is, because of the twist of the building basically starts shading itself. It's almost like a tree.
Okay.
So it starts, and
the
we
overhangs.
the overhangs, yeah. So we actually we to a degree could calculate that there was a substantial, or at least a measurable, reduction in terms of the effect on the radiance of the building, essentially. During the development, we worked quite closely with Solid Green on the green rating, or the green there was a requirement for LEED certification. So through that as well, we could have some sort of measurement in terms of to see what the impact of it is, and if it was significant to the certification process, in which at that point Solid Green felt quite confident, in the sense that just the amount of shading we could throw in the building could add a lot more benefit to the building, as opposed to a normal glass tower. So in essence, to come back to the fact that it is a glass tower, it is still a high performance, environmentally high performance glass tower, as opposed to if it was just an extruded rectangle.
Interesting, yeah.
And an interesting thing about the H-type shape is the depth of the floor plates.
Yes.
It's a lot narrower, so you have a lot more exposure from
Yeah.
all angles within the space that
Yeah.
People can enjoy the views.
Right.
Yeah.
No, sure.
It has subtle nuances, in the sense that, for instance, an H-shaped typology almost creates community, in a sense, because you have the one wing overlooking the other wing, as opposed to, you start off with a building, you have a floor plate with a core, and it looks fine, but the moment they start putting in the subdivisions and the partition walling, and then suddenly it's a core with a little walkway around it, the H shape sort of forces that, or at least challenges that sort of
I suppose
relationship.
visual connection.
Visual
Yeah.
connection and connection to the outside. For instance, one of the major things we looked at with Solid Green was about the what we call it, environmental health of the occupant, essentially, and
I suppose wellness.
wellness,
Yes.
especially,
Yeah.
which was from the start was considered in the design, and to a degree measured in. Yeah.
Interesting. Now, I understand that after winning the competition, you engaged in quite an intense design development process. I think that also included peer review between the client contractor and the consultant team for about a year. So what was the effect of this process on the design?
Well, I think the NF was a unique, not necessarily unique, but it was a way anew in many aspects. So at to this stage, we, in our branch specifically, I'm not sure in terms of Johannesburg, but we haven't been employed by the contractor. So that was a first for us. Normally we wouldn't work for the contractor. With this instance, it was the contractor was awarded a turnkey project, and
Right.
he launched the competition, which opened up a lot of unknowns essentially for us in terms of how to do the project. So a lot of it we weren't sure where it was going. We obviously had a lot of concerns in terms of what could happen further down the process, especially when
Right.
things starts going wrong, essentially. But essentially, I think it was weird for us also as a firm, where we quite we'll start drawing a building and it hits the ground, and you're still busy designing, and while this thing is climbing out of the ground.
Yeah.
And suddenly we were faced with a situation where we expected to almost basically develop the building up to stage 5 proxab before it will hit the ground. And that's all it was, to determine the exact cost of the project, which at that point for me was still, it didn't really make sense, although now it makes a lot of sense, and you can understand why a lot of European and Americans or overseas firms work the specific way.
Yeah.
But we started with a design process, and it had substantial amount of requirements. Accra is a seismic area.
Yes.
The building had to undergo peer review in terms of, so our engineering results had to be peer reviewed or verified. And I think there was also, as much as there was a sense of excitement, there was a sense of caution in terms of the severity of the typology or the geometrical challenges that the project faced. But that wasn't really dampened by sort of a spirit for achieving something great, which is, I think, sort of captures sort of where Accra's mood is. I mean, they're ambitious nation, and they're not afraid to pursue sort of ambitious ideas, essentially.
And I suppose this would certainly be quite a statement building within the city.
Yeah. I mean, it is essentially, especially in terms of, I mean, Accra is an interesting city, and it certainly is a city of dualities in a way. It's a different context. So we don't have necessarily city centres like we have here, where this building was necessarily surrounded by 6 other high-rise buildings.
Yes.
It could be right next to a house in a way. Not necessarily with this project, but I think in that specific context it would have been quite a step. Yeah.
What I just found very interesting about the whole way that the structure of the project worked is that your employment under the main contractor, you were almost left with a certain amount of vacuum in there.
Yeah.
That there was not enough other consultants to bear the project up and
Interesting, yeah.
and to basically develop it at a quicker rate. It's as if the contractor was taking a certain amount of risk up front, and with the idea of bearing it up, engineering was at a later date.
Yeah, I mean, a contractor has his way of building a project, which is different. Well, in Europe it is. A contractor has his way of building a building, which is differently to then developing a project. Essentially,
it's a completely different approach. Yeah.
Yeah. So he would use his approach and the way he understands things works, and I think for instance as well, I think with a contractor is that he's used to giving subcontractors orders, and they perform it till his to his standard or satisfaction, whereas the development of a design is just a completely different process. And
the way that you would normally approach a project of this nature is that you would have a design build situation with your consultants, and they would actually do all the the heavy lifting in the beginning and get all the specifics of the project sorted out before it gets to a subcontractor. In this case, it was to a large extent given to the subcontractors to develop, which left a little bit of a vacuum between both the client, the architect, and every other engineer involved in the project.
So do you think it was a benefit to the project? Do you think it aided the project, or do you think it actually...
From a financial point of view, it will definitely aid the project, but from a timeline point of view and quality of decisions, I think it actually hampered the project quite severely.
Yeah, I think also what you've got to keep in mind is when you work with international projects and you work with a new client as well in international context, your first hurdle is not the building, it's about developing trust. So you have to develop the trust as a professional team that he starts trusting your decisions.
Sure.
I think there's a stage where everybody sort of treats you initially like, oh, somebody just wants to make money, and run. And I think so. It took us also, a fair amount of time to show the client that, look, we have a real intention of realizing this idea, and it's not to compromise on it. And so we are aligned in terms of values and the outcome and all of that stuff. And when we start making decisions, it's for the best of the project. It's not for the best for us. They eventually develop that trust, and they start taking your advice more seriously. So I think, so for us especially, I think the first 6 months was overcoming that. I mean, if we had to do a second project with, I think, the same client, it would go a lot smoother and quicker, purely because they'll say, okay, obviously, we take seriously, what the consultants are saying, and we'll pursue it.
Can we talk a little bit about the facade? Because I see you've got some interesting prototypes here. Now, I understand you're working with multiple facade contractors from across the world. I think Brazil, Germany, Italy. Why was this the case? And really, were there any challenges around working with a dispersed team of fabricators?
Yes, I think that Gordon could probably fill you a little bit more about that. But from my experience, when you do approach it from that direction, you tend to have a lot of package systems that are being, given to the client as options, and it's priced on that basis. The most difficult part of it is to try and compare the various types of, products that they're presenting to you, and to try and get to a reasonable cost level.
Yeah, I think the reason why we sat with multiple fabricators was, once again, I think it was because of the unique process we're involved with. So we immediately, from the start, expressed the need for the involvement for a facade engineer. The contractor felt differently. He pursued a different output or outcome, which is not, once again, as I say, I mean, he has a way of building buildings, which is not necessarily the same way as we developing a building. And I think what the client was sort of looking for was to say, okay, we have a complex facade here, and it's an expensive facade. Let me open this up to different fabricators and let them come with the solutions. And we use a large variety of facade guys from around the world, and that would give us a variety of solutions and systems.
Right.
Then they could then they can reduce from this what the direction would be to pursue, and then develop it further. And the reality that we faced was where we also thought, okay, well, that's a possibility, is that in developing the cost for a facade, there's a substantial amount of risk to put a number down, and nobody wants to take that risk out of their number without knowing, A, they've got the project,
Sure.
B, they've invested a certain amount of engineering into this facade, which they're only going to do when they are appointed.
Yes, yeah.
So as much as, so the expectation was that they would, put 5 guys up, then they would give their price back, then we'll adjust the design and they'll give us feedback, or even after we've given them the design the first time, they would give us feedback to make the facade more affordable. That just never happened.
Yeah.
So
in essence, when you put a project out for tender, to leave it open-ended the way that this particular contractor did, actually makes it very hard to try and ascertain exactly where you stand with what your final product is going to be, how much it's going to cost, and how you can maybe adjust it. To try and make any design adjustment based on comments that a contractor made, it's probably going to be more for his advantage than the project's. And you have to then start looking at the building and actually engineer something. You have to come up with a solution to make this tower work. You come up with a baseline specification and take it from there and have it basically recosted. From my point of view, when I joined the project, or when I started looking into it, it was almost at the stalemate sort of stage where it wasn't moving ahead. The decision making from the contractor, or the client in this case, was really not moving in any positive direction. And what we decided to do is to basically take the tower, and have it costed almost in a complete bubble type situation where you would then create a system that would work, and then obtain a price based on that, and then start taking it in its various steps and start engineering it. But obviously, picking a system is quite a daunting task, because you first need to understand what is the design, what is the expectation of the various types of materials, etc., that would go into it, what the limits of the project is, your timelines, etc. Would you be able to do a lot of scaffolding? Would the guys be able to have access from the facade from both sides? In this case, it's a seismic building, so the facade has to have a certain amount of movement, and to make it even more complicated, it has a twist in it.
Yes.
So you need to take all those things into consideration and weigh them up against each other.
Well, I was actually going to ask you, I mean, with your understanding of and your knowledge and expertise in facade design and facade detailing, how did that actually influence the design and also that design development process?
Well, the design development process, the majority of the, I can say, the design was already done by Gordon and his team. What we needed to try and do is to take that design and move it one step further, where it becomes more cost effective, firstly, and look at the elements that's in the design that you can sacrifice and still maintain the overall look and feel.
But I think the fundamental issue we had from the start is, as much as we knew we had to make the facade cheaper, we had no measure to what extent we value engineering the facade. So because we don't have sort of a springboard to bounce back, what we've done now makes the facade cheaper or not, at that point, because that was one of our frustrations. So it's very difficult to value engineer a facade if you don't know what the impact is of the change you're doing.
Right.
Or
you almost need to establish a baseline.
Exactly, and you want to almost understand where the facade is the most expensive. So, because obviously the facade doesn't have a uniform price over its entire surface. So we needed to find out where is what is the most expensive parts of the building, almost in a way, and then how can you make that cheaper, or what is the largest surface area, and that's maybe cheapest, and how can you increase that area, because no matter how you spin it's a set amount of surface, so the glass area remains the same.
Yes.
So the only thing that will really have a major impact on it is the complexity of the cuts.
Right. Now, just talking complexity, NF Tower's model was actually developed using parametric design. What software did you use to do such modeling?
The building, it was originally conceived in Rhino. Although we are fairly advanced in terms of our BIM software, the complexity was just, it was too complex for us, for instance, to take it as into something like Rivet and really ensure that the purity of the design intent remains intact. So we actually did have a process of actually running it parallel between Rhino and AutoCAD even.
Okay.
So, and that was mainly just to ensure that planning principles remain intact. Because you work with a variable changing form, you just need to be able to make sure that you still stay in with the most important parameters, construction area on a floor plate. When you have a twisting facade, sometimes the facade creeps in on the floor plate, so you lose usability on the facade, or it creeps away. There's lots of factors that you just got to keep in mind, that even when you work with a very phenomenological type of form, which is not so much driven by two-dimensional parameters. We did then use a lot of, Rhino Grasshopper. So we were already anticipating, although when you work with a complex form, you're not really sure you're going to build this or not. You want to win the competition, essentially. That's the big thing. And that's, you've got to make a bold statement, and you're sort of like, okay, we'll win the thing and then we'll figure out how to build it. But I think we are quite responsible in the sense that, what we wanted to put on the table, we need to know what's buildable.
Sure.
So you don't necessarily want to build a competition, give it a price, then you win the competition and the client says, I want to build this thing, and that was the expression from the start with this competition. And you're like, I'm not sure we're going to be able to do this.
Yeah.
So we use geometrical principles, for instance, the use of single curvature, so it's a twist. One of the things we developed within the design of the project was we originally had more severe geometrical deformations and stuff, and we came to a conclusion where we said, look, we can make it look like the more severe original twists we did in the morning, in the beginning, but we can also enhance it through the illusions of certain things.
Right.
But then at the same time, we broke it down to basic geometric principles, and we cut out double curvature. We developed the form as single curvature, etc., etc. And that you sort of need a little bit more advanced piece of software that can maneuver itself in three-dimensional space.
So it's those sorts of capabilities that parametric design can offer that sort of regular CAD software wasn't able to accomplish, would you say?
Yeah, and it's also for variations. I think, with this specific building, there wasn't one design done for it. Even within the I think 2-3 months we had to develop the design over the different stages. It went through several iterations, and it was because we had also this close relationship with environmental performance. We wanted to measure the impacts of what we wanted to do at the same time. Yeah.
And the parametric design was kind of crucial from during the whole cost process, because if you look at the original Revit sort of models that most of the renders and everything was based on, the design is very intricate. There's lots of different materialities, and you needed to take that information and put it into a software where you can break it into a panel system.
Right,
and
okay.
Being able to do that was actually then possible to identify each individual unit, basically start listing them through, and determining what the value of one of those units are.
Okay.
And during the whole cost process, while you were accumulating this information and you were plugging it in, Gordon could feed it back into the software and basically generate more accurate cost information.
Yeah, we actually ended up using the parametric component more for measuring impact of value engineering.
So that's really how you establish that facade optimization.
Yeah,
yes.
well,
And to bring it in line
to
with
measure
budget.
it, to measure it.
measure
Yeah.
it. Right.
Because at the end of the day, this facade attracted a lot of risk, and
Yeah.
you needed to find a way to minimize that risk.
Yeah.
Now, for most projects, drawing is the communication tool. And on this particular project, I think with the complexity of the NF towers, I think you relied quite heavily on prototyping, specifically 3D printing, to communicate the complex geometry. Is that correct?
That is correct. The 3D printing part of it was more in the development stages, just to look at what you need to achieve. It's quite a complex situation where you have a basic design, which is flush glazed in this instance, with some expressed pressure caps in certain areas and some diagonal lines running across it. That can be done in a multitude of different systems, and the two main types that we were looking at in the beginning was a stick system that basically has a certain amount of seismic movement, which is quite important for this tower. Being able to take that across the twist wasn't a cost-effective way of doing it, simply because of the amount of scaffolding and the footprint and etc. involved in that. And the other is to have a unitized system that has a lot more movement capabilities. Each panel basically can act on its own little island, and the building can expand and contract in that ways. Once you've been able to do that, you could take the actual building shape and look at the panels and determine what a panel shape would be.
Yeah, I think essentially what happened was the contractor didn't want to close options, so stick system didn't make sense because of the scaffolding. So it's by far a cheaper, slightly less cheaper build, but it's more labor intensive, but it's got the scaffolding component.
And then that's also a time factor as well.
And an accuracy thing as well. So for him it was quite simple. It was about dollars. If the stick system comes in at $1 million cheaper, then it's $1 million cheaper. but there's other factors at play.
The reality of it is that even though a stick system on paper is cheaper than what a unitized is, in reality it ends up more expensive, simply from a labor and time point of view.
Right.
With a stick system, you basically have a series of mullions running up the building that's installed, and all the site measurement for those are done while they do the installation.
Okay.
Later on, they bring along a couple of transoms which are placed, and then on top of that is basically a gasket frame where the glass sits in, and that gets inserted into the system.
Okay.
It's a very good system on smaller builds. But in this case, being so big and having such a big footprint, especially with the twists on the sides of the tower, would require quite a lot of scaffolding for the duration until the building is topped out.
Right.
And from a time perspective and cost, it was just not a reasonable solution. It has limitations from a movement point of view as well, simply because you've got a vertical line that runs through the building. You basically have a very limited movement in this direction, although you have a certain amount of movement in the up and down. Unitized is a little bit more expensive to produce, but once on site, you basically install it straight from the floor plate. You don't need to have scaffolding everywhere, maybe on a couple of interesting corners where you can't reach.
Yeah.
But the most important part of it is that you can actually have the product fully manufactured in the factory and delivered to site and installed without having to spend too much time.
Gordon, tell me a bit about the prototyping process, specifically in the actual competition submission, and then throughout the project.
Yeah, so we were in the process of developing the competition for presentation. So it was literally about a week before the presentation, and I was, we threw everything in the kitchen sink at this competition. We really went out all the way with this. And we've done everything. So we had posters, we had books, we nearly had a thesis, not even a book. And then I had a conversation with one of my colleagues, and he said to me, you know what, the guy with the model always wins the competition. I said, well, thanks, that's not really going to help me now, it's a week.
Yes.
So we did we searched, and we found this sort of like renegade cowboy model builder. I think he was retired as well, on a plot outside of town, and he was willing to build this model for us in a short period of time. I think it literally had like 6 days, and he had a reputation for never finishing on time.
So slight risk.
Big risk. And anyway, so he managed to pull it off on the last minute, literally. We flew over, and so we did the presentation in Accra, and we sat in front of a panel of bankers. The client's a banker. And his representatives from the States, all kinds of stuff, and we did the presentation. Everything went smooth and fine, but you got this feeling that you just met with pale faces.
Okay.
And then right at the end, right after we did the animation, we opened up the model, and it was sort of just like this light went on in the room, and people got it immediately, and you could, and it was an energy you could almost kind of feel. And I think that's also for me like a turning point in my career as well, where I sort of realized again the value of prototyping. And I think in the spirit of the project of how we originally developed the design, we tried to continue it through the process. So continuously developing the design into its real form, in a sense, or the buildable form. We used modeling the whole time as a means of communication. We found that a simple mass model said a lot more than any CAD drawing can communicate. It's just not possible, and it instills a sense of confidence. It's kind of weird. It's sort of, you can show a complex animation of any type of building, but there's an emotional disconnection from it, in the sense that it's not real. The moment I give you a rudimentary model, you believe it can be built.
No, it's tangible.
And it's tangible, and it gives a project momentum, which it needs, and especially in the design development stages. That sort of approach we continued, and so when we got to the facade stages, and we once again finding ourselves in stalemate and without direction, and trying to find out, we've got a contractor saying to us, what system should we be using? And we're saying to him, we need an engineer. And he's saying, you're not getting an engineer. And we're like, we need an engineer. We're not getting an engineer. We started looking at, we turned to our own internal knowledge.
Yeah.
So we looked at buildings we've done. So for instance, we would look at, let's say, a building like Discovery and say, okay, what was the fin system used? We had, besides the glass facade, we had an external fin which added to the complexity of the building at some point. And then taking the internal knowledge we had of facades, that we've had experience, and this is where I could sit with Herman, and he'd say, like, look, we used this system, and we know, at least within certainty, it's not the same building as that, but we kind of know how this is going to respond.
So something tried and tested.
Tried
Yeah.
and tested. And,
Yeah.
you basically have something to start off with, and you can start developing from that point.
And I think what's interesting then is I think at that point also in our Pretoria office we recently got some new fabrications hardware as well, and suddenly there was sort of like this invigorated process of trying to figure out how this thing works, which is the way it needs to be. So we were looking at the way the fins were going to rotate or twist around the building, and suddenly we had directors modeling in SketchUp models using their technological expertise, and we ended up building these sort of mock-ups of theoretical facade systems based on hybrids of what we've done. And then that also then helped us to sit with the sort of the international collection of facade fabricators to say, this is our intent, because that's the important thing we had to communicate with them, is what is our intent. So it is a lot easier when you sit with in a meeting and we tell them, this is what the facade needs to do because of that. Yes. One of the paradoxes with facades is it's just the way the design process works. There's the architect would develop the design intent, he would go give it over to a facade engineer, he takes your software, most cases BIM, which means nothing to him. He takes that software, he reinterprets a new facade into vectors, and then from that he develops the fabrication model. But the fabricated model never returns to the designer.
So true.
Yeah. So you have the building in its most vital stages sitting with a facade that is not what is being built. And so how does your building that responds to that facade, how does it work? And I guess it's a lot more complex when 90% of the surface of the building is glass.
Yes.
Versus punch holes. It's covered in glass surface.
So now the structural engineering on the building must have been quite a challenge as well.
Yeah.
How did you resolve this balance between the structure and the facade without compromising the floor plate?
This was quite an interesting situation, because the structure was almost set in stone at some point, where the facade had to follow suit.
Interesting.
Yeah, the normal process of working with a curved facade is that the moment you go away from a standardized rectangular panel, the process would be you develop a form, you apply the pattern of window that you require on the facade. Then the form has to be recalculated for an optimized panel form. So it requires a form modification that forces the panelization to work. Because we went into this sort of back and throw where we couldn't get a facade engineer appointed, the building development of the building didn't stop. And it got to the point where even if we got the appointment of a facade engineer and he could come with a solution and say, well, we're going to recalculate the facade form that's going to result in this massive cost saving that we require, the logistical issues was just not possible. So we can't just now go back and redraw the entire building that we've spent a year on. And the challenge, but I think, the challenge was how to find new, I think, creative and innovative solutions to apply it to the form without altering the form. That's also not sort of resetting the design process. But I think fundamentally, the luck we had was that because we developed the facade on sound principles initially, or the form, we could try out interesting alternatives that could be applied to this form within a single curvature, and this is where Herman came up with the idea of, well, let's actually break away from the rectangular panel and we go for trapezoid shapes. And if you take the trapezoid shape, which now seems inefficient, but you just have to rotate it like that, and it's a straight panel with.
Yes. The main important part with that, Nisha, is that if you start modulating across a set facade, you can end up with malformed mullions to try and follow that shape. And what you want to try and do is try and keep them as regular as possible, running along the facade, so that you have repetition. Because each individual panel that goes in there has to be moved from somewhere. Can fall, can break, and you need to be able to replace it with another one from another location in that place, so that you don't stop. And you had to find a way to try and repeat that. And having these two surfaces and trapezoiding the one side of it meant that entire surface start having something in common with each other.
Okay. How did you approach the programming of the interior spaces?
In terms of the physical programming of the interior spaces.
Yeah. So the mix of use.
Yeah,
if I
I mean
understand
it's
correctly, it's
yeah,
not
it's
just an office tower.
No.
no, it's a mixed-use tower, but it's not an Asian mixed-use tower. It's an African mixed-use tower. I think for me, it was probably one of the most fascinating components of this building. I think, and it probably comes back to, Dewar's got the saying, "Out of Africa, always something new," which is a quote from somebody else. But so part of the brief was for a mixed-use high-rise tower. So I mean, to be technical about it, it's not really a high-rise building. It's about 19 or 20 stories high. The second thing was, if you look at the programming in terms of what it required on that specific floor plate, it's just complete madness. It's it starts off with the ground floor of retail, then it goes over into conferencing. Firstly you want to put conferencing at the top, then it goes into a wellness floor with gym facilities, then a whole set of levels for offices, then technical rooms, then hotel, then restaurant, then penthouse, then plant room. And then it still required a lot of future proofing in terms of there was a relationship developed in the competition with an adjacent site where a hotel was located, and the hotel had to be relocated into the high-rise building. But the moment it does that, then that site gets redeveloped, and at some point that hotel has to move back then, and then what happens to that? And then I think then there's also the uncertainty of how, I think especially in a country like Accra, where a lot of the stuff is new, so there's no guarantee that everything is future-proof. So how do you future-proof such enormous amounts, such a large set of variables, essentially? But I think it was probably one of the beautiful components of the project, in the sense that the engineering enabled us to achieve that, in the sense that we could push the engineering to such an extent where the form of the structure not only enhanced the function of the building, but we could even push it further, because for starters, as well as the engineering required, as opposed to normal vertical towers, is substantially more. The peer review pushed us even farther. We had to even show more proof that what's going to work. And the thing with such a building is that you can't over-engineer it, because of the twisting nature of it, the weight works against it. So the engineer would design it to deal with certain seismic conditions and twisting forms, but then he has to really find that sort of like the sweet spot where he just has the right amount of engineering to it. Going through such a severe process of engineering, you can challenge a lot more. And for instance, so we managed to develop a clean floor plate that has got only columns on the side. We have literally no downstand beams in the entire building, except within the basement. There's a few. So essentially, we have this clean floor plates that can be reprogrammed into anything, essentially. So the client can decide after 2 years, make the hotel something else, and it's possible.
And the interesting part about the entire structure is that you've got this twist in the building. firstly, and you need to find a way in this seismic condition to stabilize it. And the structure is designed with sloping columns pushing back. To prevent it from over twisting. And then during a seismic event, obviously the expected movement that it would go backwards and forwards, and everything had to be designed to take that expected movement. Even though the core has a larger amount of movement, because that's obviously where the spindle or the axis on it sits.
Right.
The outside has quite a wide fly out as well, and everything had to move with it.
Well, I think what made this one a bit also more complex, it actually had two twists. So it had, and they were asymmetrical twists. So the building twists around the core, but the offset balance is asymmetrical. Which makes things a lot more complex. So I don't twist buildings.
So having gone through this process and then developed these particular expertise, how would you approach the next tower building?
Square.
With confidence. I think with a lot more confidence, because you would know what to expect in the end of the day. Even though you've made decisions in the beginning of this particular project that might have had a good result in the end of the day, the next time when you make that decision, it would be with greater intent and with a better result.
Well, I think you as a person, as a professional, and even as an organisation, you expand after a project like this. The amount of knowledge that is developed within in such a process, it pushes you, and you're different than you was before. I certainly do have a lot more appreciation for simplicity, but it definitely, I think, for future projects, it definitely, we had so many unknowns, and by sort of working through this process, you sort of realize that, if you follow the process, if you trust the process, anything is really essentially possible. So even if more complex buildings come their way, for instance, if better now what to do or what not to do,
and more equipped, I guess.
Yes, and you can make more informed decisions.
And I think looking back, when, for instance, just in hindsight, when we got to the point where the client sort of said, look, we're not going to give you a facade engineer, next time I would just insist, like, we're not going to continue if we don't have this, period.
But do you not think that out of that process, or through that limitation, that it also pushed the design?
No, absolutely. But I think in hindsight, things always looks a lot simpler. But that's unfortunately, I think, it comes back to the uniqueness and the beauty of Africa, and I think, and it's sort of also, it's not a negative thing, and I think if you tackle it in the correct spirit and the right spirit, what's possible in a continent like Africa is just incredible, because you can actually go there and say, we're going to do this double twisting building in a seismic condition, with a lot of other parameters, and engineer a solution for it that's workable.
So I recently read an article, it was actually from technology group Siemens, that they predicted that by 2050, 1.4 billion people will be living in an African city. So do you think this type of building typology is relevant to the future of many of our African cities?
I'm not sure, actually. It's I think, once again, Africa is such a complex place. Our experiences here in Accra does not apply next door in Ivory Coast. So we're moving into we're involved with a project now in Ivory Coast, and it's a different animal, different set of rules. And so even in a place as Accra, I think it definitely does have a purpose, but it's not necessarily always urbanistic. For me, in this instance, it reflected the aspirations of a nation.
Right.
It's a proud nation that wanted that sort of demands its international recognition, and that's what they demand and need. So, but it's definitely a unique model. I think for us as architects, though, the responsibility is to address those needs and aspirations, for instance, but in a very responsible manner, in the sense that the solutions we provide is sustainable. It is it's what's the correct word?
Well, I suppose appropriate to context.
Yeah. And resilient, sorry. That's resilient in the sense that economic times are, it's unpredictable, and when you don't have sort of, you know, just to give a good example, I mean, with this specific project, you know, the amount of challenges are so enormous. For instance, if you look at services, the building was nearly almost off the grid because you don't have proper infrastructure, sewage connection, water, you know, generators. You know, you've got the problem of, you know, diesel being cheaper than electricity. Electricity is expensive. At the same time, a diesel generator gives a more stable electrical current. So they prefer to run it off diesel. So I think it's definitely when you do a building like that, it condenses its footprint in a way.
But don't you think, Gordon, that the aspirations of African countries in general is an ever-changing animal? It's something that evolves on a daily basis. In this instance, this is, as you said, a pride of a nation, something that they required at this stage. But next year, the following building or the building after that will have a different requirement and a different need, and it just adds to the whole spice of what's to come, basically.
Yeah. Absolutely, I agree. Yeah.
So before we wrap up, would you have any advice for young architects who are tackling the design of a high-rise building?
Carefully.
No, trust the process. I think it's fundamental to any design development. I think a building without process has got no depth, and I think also to embrace the unknowns, not knowing. I think, you know, if you want to create responsive architecture, you can't enforce your preconceived ideas onto any set of parameters. By responding to your context, the conditions, the program, following a process, you'll get to a result somehow that's appropriate.
Thank you both. It's been wonderful. It's been a lovely conversation, and I really appreciate you sharing your insights.
Pleasure.